I'm waiting. The tutor gives me the license for Zoom. We have some licenses for Zoom. And when you have the license, it doesn't stop every 40 minutes. But somehow I did not yet get it. So I hope I will get it, then we don't have these interruptions all the time. On the other hand, let's just take the chance for a small break. So who can explain to me what this picture shows? Yeah, Shima?
It shows how can we solve a real world solution, or I mean real world problem.
Yes, exactly. Do you want to
So
explain the steps?
yeah.
Okay, go ahead. Very good.
So if we have a real world problem, we can solve it in two ways. We can we can solve it by our experience direct, or we can do these steps.
Yes, yes, exactly. So we can either go from 1 to 4 directly by using our experience, or we
Yeah.
can take this detour trying to set up a mathematical model and using a solution approach for this mathematical model. And then we have a problem or a possible solution for the real world problem. And what happens then when we go from 3 to 4? Do you know, Shim? Yeah.
When we go from 3 to 4, we have to see if that solution is good enough to
Yes.
solve the real world problem. If it is not enough, we have to do these steps again and again
Yes.
until we have a good solution for this problem.
Yes, exactly. Very good answer, Shima. Thank you very much. Thank you. So, for example, if you want to decide about your inventory policy, you might model the situation so that you can apply the economic order quantity. Yeah? This is a very simple mathematical model. You solve this mathematical model, you can just calculate the economic order quantity, and then you check if the economic order quantity is really a good problem for your real world. If this economic order quantity is really a good solution for your real world problem. Maybe we did not take into account safety stock. Maybe the demand is not as predictable as we think it is. Huh? And then we need to make modifications in our economic order quantity model and apply it again to the real world. Yeah? So this is how you solve the real world problem. And often we just focus on step 2 and 3. So last year, I asked you to calculate the economic order quantity or apply the news vendor model or apply the center of gravity method. This was always step 2 and step 3. These were the focus of the things we were doing. But actually, in the real world, you should be able to modify these basic methods to adjust them to the real world. Okay, very fine. And the last thing on this slide is that you should keep in mind the difference between the problem, the model for this problem, and the solution method or algorithm to solve the model. So the algorithm solves the model, and the model is a representation of the problem. But for one problem, there might be many different models, and for each model, there might be different algorithms that are able to solve this model. Okay. Now let's look at a more complicated example. The problem that we are studying is which of the customer orders should be accepted by a company. Therefore, it's the acceptance of customer orders. And it's just an example problem, and I want to focus on the steps that we take to build this model. So we have a company, Aisha Furniture Manufacturing, AFM, in Muscat, and Aisha has 4 customer orders for the next months. 4 orders from customers. The problem now is that the machines this company has, the capacity of these machines is limited. So therefore, we are just not in a position to perform all the orders that we got. And now Aisha has to decide which of these 4 orders should be accepted, though that the total contribution margin becomes maximum. The total, let's say, in a simpler way, the total profit becomes maximal. This is our problem, and we need to make a decision about this problem. So what is the available data? For each order, we need 2 machines. And we write one machine with the letter J and machine 1, and we have machine 1 and machine 2. So if J has the value 1, we refer to it as machine 1, and if J is 2, then this means we are talking about machine number 2. Capacity Cj in operating hours of machine J is limited. So each machine J has a capacity. The capacity of a machine is Cj. So we have a capacity C1 for machine 1 and the capacity C2 for machine 2. And the capacity is measured in hours that the machine is working. And for the next months, the machine number 1, C1, is available for 110 hours. The machine number 2 is available for 90 hours. Why the difference? Maybe there are already other orders that have to be performed on these machines. Maybe there's some maintenance. Maybe the engineer who operates these machines is not available, is on holiday or whatever. So this is the reason why the available capacity of the 2 machines is different. Aisha calculated the contribution margin. We denote this margin with the letter U of I. This is just the price of the product minus the variable costs of each order. And the orders are denoted by the letter I. So we have 4 orders, so I can have the value 1, 2, 3, or 4. And the contribution margin is for the letter I, for the index I, yes. And Aisha already determined how much capacity an order I requires on machine J. So in the rightmost column of this table, we have the contribution margin U, and we have a value for each order. We have 4 orders. Orders are denoted with the letter I. So that means the contribution margin, price minus the variable cost of order number 3 is 2,000 Omani Rial. For order number 1, and the first line of this table, the contribution margin is 5,000 Omani Rial. Now, what do these two columns mean? What does the value 20 mean? What does the value 20 mean? Try to figure out what is the meaning of the value 20. That's more complicated than the contribution margin. How to read this table and what is the meaning of the value 20 in this table? Yes, Abdullah, you're right. These 20, this is the amount of hours, the number of hours that we need if we manufacture order number 2 on machine number 1. Yeah. The I in the Aij refers to the order and the J to the machine. We have 2 machines, 1 and 2, and 4 orders. So the 50 means if we produce order number 4, we need 50 hours of machine number 2. So it's important to understand exactly what the given data means. And our question is, which of these 4 orders should Aisha accept to maximize the total contribution margin? We have 5 steps in building a decision model. First of all, what are the objects that should be considered? We have in this problem, we have 4 orders denoted by the letter I and 2 machines denoted by the letter J. Other objects that are part of this model are the relations between orders and machines. So what is here shown in this table, how many hours do we need to produce one order on a specific machine? This is the third relation. And then we look at the attributes of these objects. And in number 2, what are the given attributes, or we call this exogenous attributes? What are these given attributes? Another word for this from the mathematical language is parameters. We have the parameters contribution margin. So everything basically that's shown in this table. We have the contribution margin for each order. We have the available machine capacity, and we have the required capacity that we need to manufacture one order on one machine. These are the given data, the given attributes of the objects. Now, what are the wanted attributes? We call this, in this context, decision variable. So what is the specific value? What are we looking for? We want to decide for each order, shall we accept this order or shall we reject this order? Can we tell the customer, yes, we will do your order? Or do we have to tell the customer, sorry, we do not have capacity for your order. Please come back later. And we call this a decision variable. And here I denote this with xi. So we make this decision for each of the 4 orders, therefore I. And if this variable has the value 1, then that means we accept the order I. If this value, if this decision variable has the value 0, then it means we reject this order. Shima, you have a question?
Mister, I want to ask you a question. In orders, we have to use both machines or one machine only?
To fulfill an order,
Yeah.
you need both machines. You can see this from this table. Yeah. So for example, for order 1, if you want to fulfill order 1, then it means you need 30 hours of the first machine and 40 hours of the second machine. It does not mean either 30 hours on the first machine or 40 hours on the second machine. It means both. Yeah, so for each order, you always need the 2 machines.
Okay, Mr. Clear.
Yes, welcome. So we have 5 steps for modeling this, and on this slide there are the first 3 mentioned. Yeah? If you want to build a model, we need to be clear about what are the objects that we want to include in this model. Yeah? What do we want to include? What do we not want to include? And here we want to make a decision about the orders, and we need to take into account the 2 machines and how many resources are required to produce one order on one of the machines. Then we have some exogenous attributes of these objects. So this is everything that is given. Yeah, this is on this slide. This is the given data where the problem is explained. We know this data. We can consider this data as given, and we are given here the contribution margin for each order, the capacity of each machine, and the required capacity to manufacture one order on one machine. And these given attributes are also called parameters. Now the third step is to decide what do we want to decide, what decision do we want to make, and we call this decision variables. And the decision we want to make here is, shall we accept an order I or shall we reject it? And if we accept this order, we say this decision variable xi becomes the value 1. Otherwise, if we reject it, it becomes the value 0. To explain, I'm not expecting that you are able to build such a model now from scratch and follow these steps. Yeah, this is not what you should immediately learn, but what you should somehow understand, that we have these steps. What's the difference between these steps? And that you know the difference between parameters and decision variables. You will have in this course and in other courses more opportunity to actually build these models, but this is just the basics to have some terminology and to get a rough idea how this works if you want to build a model. Now let's go to step 4 and 5. So we need something that we call objective function. And by an objective function, we try to measure what is a good solution. Yeah? How is a good solution characterized, and what should be the properties in order to decide what is a good solution. And the objective function usually always tries to combine the decision variables with the parameters. There's always some connection, at least between some decision variables and some parameters. And finally, we have something that we call constraints. This is again a link between decision variables on the one hand and parameters on the other hand. And this describes how our decisions depend among each other. And what we need to model in this problem, we need to make sure that we do not produce more orders than we have capacity on our machines. So this is somehow a constraint. We need to take into account that the time we can use a machine is limited. Yeah, would be a constraint that we need to model somehow. And the goodness of a solution, this will be related to the total profit that we are able to make. The more profit we make, the better the solution. Though this is related to our objective function in this context.
Mr.
Yes?
When we make the decision, we have to choose one order, or we can choose many orders?
This will be decided, or this depends on the way you build your model. Yeah, you have one problem, which orders to accept, and now depending on how you build your model, it might be only one order, but it might also be more than one order. So this model that I'm going to present to you here is able to accept more than one order. Yeah? But this is a modeling decision that the manager who tries to solve this problem has to make. What is the most appropriate decision? What is the most appropriate way to model this problem?
Yeah, thank you.
So now we have these abstract concepts and we write it down in a mathematical notation. We call this notation how we want to talk about these different objects. So we have our customer orders. If we just pick one customer order, any customer order, we use the letter small I. If we talk about any machine, we use the letter small j. We have the parameters. How many resources does order I require on machine J? This was in the table. We have the capacity for each of the two machines. This was also mentioned in the text of this exercise. We have the contribution margin of an order. This was as part of the table that was given. And we have the decision variable. So we're just summing up the notation for this model. And now I'm showing you one way how to model this problem. And for you, it's not that you try to memorize this problem or this model. It's more about trying to understand how we got to this model and what this model is telling you. It's no need to memorize this model, but you should be, to a certain degree, able to understand and apply this model. And this is how this model looks like. Yeah. So here on the right side, I have a number for each function, for each equation. And number one, equation number one, this is the objective function of the model. Here we measure how good a solution is. So where is this 5,000, 4,000, 2,000, and 10,000 coming from? What do you think? Where is this coming from?
Which one, Doctor?
In the function number one, we call this the objective function. Then we have 5,000 times x1, 4,000 times x2. Where are these numbers coming from? 5,000, 4,000, 2,000, 10,000. Why are they suddenly here? Where is this coming from? Yes, contribution margin. Mara, you're right. So this was a contribution margin. I go back to the previous slide. Yeah, these are the numbers here on the rightmost column. This is the contribution margin. So if we do order number 1, we earn 5,000 in profit. If we do order number 2, we earn 4,000 in profit, yeah, etc. If we do order number 4, then we increase our profit by 4,000. And recall this X was a decision variable, and X can only have the value 1 if we accept the order, or it can only have the value 0 if we reject the order. Now, what is the value for the total contribution margin for this solution? When X1 has the value 1, X2 has the value 0, X3 has the value 1, and X4 has the value 0. What is then the value of that? You just need to take the solution, these values of this decision variable, and enter it in Formula 1.
Mister?
Yes?
I don't understand that one.
So you have a solution. It is already shown here, right? So you have 4 decision variables, x1, x2, x3, x4. And the value of the decision variable x1 is 1. The value of decision variable x2 is 0. x3 is 1. x4 is 0 again. This is given. And now you just enter these values into equation number 1 and calculate what's the outcome. And here in the chat, there are several students that say the outcome is 7,000 exactly, yeah? But I gave you these values, yeah? I specified them myself, and I just want to know what is the value for Z if I enter this. I did not use a method to come up with these zeros and ones. Yeah, so it's just given. You have to enter it. And when you substitute it and calculate the value, then the outcome, the goodness of this solution is 7,000. Now, what does it mean? What is the meaning of this solution? What is the meaning of this solution? What is the practical meaning of this solution? Which orders are now accepted and which are rejected? Be careful. 1 and 2 are not accepted. Yes, order 1 and 3 are accepted. Correct, Faisal. Order 1 and order number 3 are accepted. Order 2 and 4 are rejected. Yeah, this is the meaning of this model, yeah, of this decision variables, are the consequences. Our model contains more than just this objective function. We also modeled in number 2 and number 3 the constraints of our machines. And the equation number 2, the inequality number 2, is modeling the capacity constraint of machine number 1. Recall, for machine number 1, we have 110 hours available capacity. And now if I go back to the table with the given data, so on machine number 1, we need, if we produce order 1, 30 hours. If we produce order 2, we need 20 hours. etc. And this is modeled here. If we produce order number 1, we need 30 hours. If we produce order number 2, we need 20 hours. If we produce order number 3, we need 60 hours. If we produce order number 4, we need 20 hours. And the same applies for machine number 2 and their respective capacities. Now I have another solution here. I give you this solution. X1, X2, X3 are 1, X4 is 0. That means we accept orders 1 to 3. And now what is the value of the objective function and what is wrong with this solution? So 11,000, 5,000 plus 4,000 plus 2,000. So 11,000, that's the value of the objective function. Of course, it's better than 7,000. So this solution looks better than the previous one. We make a higher profit. But now what is wrong with this solution? When you check equations number 2 and 3, what is wrong with this solution? Or is there something wrong? Maybe nothing is wrong. It's just to trick you. Is it possible to manufacture the orders 1, 2, and 3 on our machines, or is it not possible? And how do we see it? Yes, maybe it exceeds the limit. Now we need to decide, does it exceed the limit? Yes or no? This is done via equations number 2 and 3. So you just have to enter these numbers into equation number 2 and see if it's okay, if the left side is smaller than the right side, or if it's not okay and something is wrong. They are equal, right? So if we enter it, then we have 30 plus 20 is 50, plus 60 is 110, plus 0. So on the left side, we have 110 is smaller or equal than 110. So it means this constraint is fulfilled. So we have no problem with number 2. They are exactly equal. That's fine because we write smaller or equal. For number 3, 40 plus 30 is 70, plus 10 is 80, plus 0. So 80 is smaller than 90. That means we have a profit of 11,000 and the equations 2 and 3 are both fulfilled. That means we can accept the orders 1, 2, and 3 because we have enough capacity and we will make a profit of 11,000. So nothing is wrong with this solution. We can accept it. Though the idea is you should not know right now how to get to the proper values of 0 and 1s. You should just understand how to calculate the profit and check if the constraints are fulfilled or not. And here they are fulfilled. So this is a feasible solution. We can make this decision. It's not a problem from the business perspective. That's all that you need to know. You don't need to know how to get to these numbers right now. That's not the learning outcome from this order acceptance model. But you see how you can transfer a business problem into a mathematical problem. What are the basic steps? Even if you might not understand all the steps or could not do it yourself without the guidance of the existing model, but you can already have some understanding of this model when I show it to you. This is what's already happening. And in the course Operations, Research and Management, in the next semester, you will see some methods how to calculate the optimal solution. And you will see that the optimal solution for this problem is accepting orders 2 to 4, and the objective value will be 16,000. So our time is up, unfortunately. I recommend to you to do the exercise on how to learn how to learn. I uploaded a YouTube video on this slide set. I think this will be a very valuable exercise that helps you reflecting. And I'm looking forward to meet you next week again. See you soon. Please sign up for the Microsoft Teams group. Yeah, our time is up. It kicks me out shortly, but I will not restart the session again. Thank you so much for joining me, and see you next week.